Hey everyone, this week's topic is system of equations. And really what systems of equations are just, when you have two linear equations. So basically you have two lines, so let's say you have a graph. Okay, and so let's just say one line represents like how much product you sell, right? So you can't sell negative products, so I'm just going to start from 0, right? So that's like how much of an item that you sell in your store, right? And then it costs money to make products, right? So maybe you have another line that's like how much money you make versus, like your profit. So you have two lines, like, right, number of products sold, money made / lost. Oops, it got cut off. Right, so you have two lines. Okay, and what they can represent basically is these are two equations. We don't have the equations, but they're there nonetheless. And they intersect at one point. Right, so this intersection can tell you a lot. This is probably where you break even. Right, so before this, you're losing money. Right, you're selling some product, but you need to sell a certain amount, right? Because you have to put money into your products. You have to get all the equipment you need to make your product, right? All of that kind of stuff. So you lose money, but then after a certain point, if you sell enough, right, and then you will break even. That's what this point represents. And then at this part, above that break-even point is where you start making money, right? So that's this is just kind of like a real-life example of a system of equations. You have two equations, two lines, right? And we want to find that point where they intersect. Okay, so this is the solution. Okay, so when we are solving for a system of equations, we're trying to find that intersection point. So it's actually, there's many ways to do it. This first video is going to be about how to solve systems of equations by graphing. Okay, so you might be given two equations. Right. Okay, so you have two equations, and they say solve, it'll usually say solve these systems of equations. So here's the two systems, the two equations. I'm going to graph them. So just like graphing lines, we're doing the exact same thing. The only difference is that now we're putting two lines on the same graph. So before we were just graphing one equation, right, on a graph. Now we're graphing two equations. Okay, so this first one, I'm going to use the slope-intercept form. The slope here is equal to 2 over 1, right? And my y-intercept is equal to 0, right? Because you could just write that as y equals 2x plus 0. So that means I start here. My slope is 2 over 1, so I go up 2 to the right 1, up 2 to the right 1, and then I'm just going to draw my line. It's a good idea to label your lines because now you're going to have two lines on the same graph, so you want to label it with the equation so that you know which line refers to which. Right, I'm going to rewrite the second equation in slope-intercept form. Sorry. All right, there you go. So my slope here is -3. Y-intercept is 10. Oh, darn it, I don't have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, and then my slope goes down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. I don't think I did that right. 1, 2, 3, 4. Oh yeah, I didn't. This is why it's always a good idea to use actual graph paper. Oops, shoot. Because when you don't have a nice grid, Jesus, this is annoying. Smaller eraser, please. Am I not? Sorry. Oh, that's the smallest? Okay. There we go. Okay, down 3 to the right 1, down 3 to the right 1. There. I knew, because I knew it had to actually intersect at a point. So 2, 4 is where these lines intersect. Yeah, so when you're doing systems of equations, I'm doing this freehand, but it's really important that you use a actual grid, like graph paper, or that online graph paper, which again I can link it down in the description box for you, because when you try and do it freehand like this, then it's going to be hard to see, like, where does it intersect? You're going to have to kind of estimate things like that, and your answer will probably be wrong, right? So if you're going to solve by graphing, please use graph paper, so that you can actually get an accurate result. The only reason why I knew it wasn't supposed to intersect there is because that's the example I have written. But otherwise, hopefully that makes sense. See, I just graphed the first line there. This graph is the second line, right? Remember, this is our first one, this is our second one. I'm just graph them, and then we just find the point where they intersect, and this is our answer right here. Just that point. Pretty easy, right? Just the intersection point. And yeah, let's see. So just do another example. Okay, so we've got 2 lines. The first one intersects at, the intersection point is 4, and then my slope is rise 1 to the right 2. So about there. 1 to the right 2. Again, please use graph paper when doing this. I'm probably gonna find a way to like superimpose the grid onto here. Okay, and so that's our first line. This is, I just graphed it just like we did last week with all basic graphing. So this should all, you should know how to do this before. And then now the next one is go down 2 to the right 1, down 2 to the right 1. Okay, this is my other line, my second line, and I want to find the point where they intersect. I chose this one because luckily they just intersect right here, right? And that point is 0, 4, right? So my answer would just be 0, 4, the point 0, 4. Something else I just wanted to point out, this line is actually perpendicular. right? That means that like it forms a right angle. So you can think of it as like an intersection. Intersections are, you know, besides those weird funky ones, intersections are two lines that cross each other perpendicularly. And they form right angles. You can tell when two lines are perpendicular if you look at their slopes. Hey, I'm not going to test you on this. It's not on the like homework or anything, but it's just handy to know. But if you look at the slopes, right, the slopes of perpendicular lines are the opposite and reciprocal of each other. Right, so the slope of one line was 1/2. So the opposite of that would be negative 1/2, but then you have to also do the reciprocal. So the reciprocal of negative 1/2 is -2. And you can see that's what the two slopes are over here. And so it's just like a handy little trick to spot perpendicular lines, or if you have to like create equations and it says make an equation for a line that's perpendicular, you can use this trick to figure out its slope. Another common one is parallel lines. Parallel lines are lines that never cross. So we can do an example. So if you had a system of equations, it says solve for it, but then they end up being parallel, they have no solution. They never cross each other. They don't intersect. Okay, so let's do an example of parallel lines. Okay, going to solve each one for y, write it in slope intercept. So the first one, do 2 over here. 30. Oops, that's not 15, sorry. 15 divided by 5 is 3, right? Always remember to carry over. Okay, so now I'm going to graph my two lines. I've got them in slope-intercept form, so it should be pretty simple. If you notice, the slope of each of them is the same, right? So if we do the first line, we start at 3, we go down 3 to the right 5. Ugh. Totally missed my point. The first one is 6. It goes down 3 to the right 5. And again, if you do this on a grid with a ruler and everything, everything's straight, then these lines are always staying the same distance apart from each other. These are parallel lines. And if you look at them, it's because they have the same slope. So it makes sense because each line is changing at the same rate as the other. So this is why they are never ever going to cross each other. So if you ever see parallel lines, or you see like a system of equations and you notice they both have the same slope, then you know that they have no intersection. So that would be your answer for like this system of equations. Say no intersection point, they're parallel lines, it's not possible for them to ever cross. Okay, but so that's solving systems of equations by graphing. Hopefully that's pretty straightforward. It's just like what we did last week, except now you're going to put two lines on the same graph and you're going to find the point where they intersect. Okay, and that's your answer. The answer is an intersection point. Right? So that's solving by graphing. We'll move on now to solving by other ways.